DNS, or the Domain Name Service, helps us make sense of the internet by giving human-readable names to IP addresses. DNS is a huge topic, and I can't go into it in depth here, so I encourage you to check out Managing DNS Essential Training. What we're going to do in this video is set up DNS on our router so we can refer queries to our gateway for the 192 network. The software we'll use for the DNS server is what runs most of DNS on the internet. It's called Bind, but the program we'll be using is called named, short for name daemon. On our router, we'll set up what's called a forwarding DNS server. This kind of server sends requests for DNS information to other DNS servers. So if I were to ask for the address for example.com, that request would go to my router 10.0.2.6, which would then forward it right on to the next DNS server in the chain. Here on the router, I'll install bind and bind utils. I'll write sudo yum install bind utils, and I'll accept. And then I'll edit the configuration file, which is called named.conf, with sudo vi etc named.conf. I'll change the address that the service listens on, here on listen on for IPv4, to any, and also for the v6 one. I'll change that to any. Then I'll set up an access control list to specify who can use this DNS server. It isn't public, so it's not a big risk, but it's a good idea to set limits anyway. Here I'll add an ACL for access control list, and I'll call it allowed. Then I'll open a brace and put in my networks, 192.168.0.0/24, semicolon, and 10.0.2.0/24, semicolon. And I'll close that block with another brace and another semicolon. Now further down in the options block, I'll change allow query to open it up from localhost to any of my allowed clients for my ACL. Then slightly further down, I'll disable DNSSEC because I don't need that here. And I'll add a block called forwarders. This will be the list of servers that we're going to forward requests to. So in my case, it's going to be 192.168.0.1, semicolon, closing brace, semicolon. And then I'll tell the service to only forward traffic. So I'll say forward only. That means basically don't act on it for any reason other than to send the request on to another server. That's it. Now I'll save and quit, and I'll enable and start up the service with sudo systemctl enable named and sudo systemctl start named. And before we go use the server from other clients, we need to open up the firewall to allow those clients to talk to it. So I'll do that here with firewall cmd. I'll write sudo firewall cmd and make it a permanent rule. I'll set the zone. I'll specify the public zone, which is where we're working. And then I'll write add service equals DNS. The add service argument lets you specify services by name rather than by port and protocol. FirewallD will read this and know to open up TCP port 53 to let DNS queries go through. So I'll reload the firewall with sudo firewall cmd reload. And let's switch over to the client on the 10 network to see if we can resolve names through our new service. To do that, I'll use the NSLOOKUP tool, and I'll give it a domain name, let's say linkedin.com. And as a second argument, I'll specify a server to send that request to. So I'll write 10.0.2.6. And there we go. The last step in using this service is to update my client's DNS entry with the router's address instead of its own gateway address. So to do that, I'll write nmcli conmod my Ethernet IPv4.dns 10.0.2.6. And I'll restart the connection. All right, and now if I just do a regular NSLOOKUP for, let's say, google.com, I can see that my request is going through my router. That's exactly what we wanted.